Good afternoon everybody. Today we will discuss numerical problems on error and accuracy. So this is a vague type topic. Like first we will discuss what are errors and what are different type of errors, and then we will discuss few numericals related with different type of errors. So first is error. If we are making physical measurements, there is always an error involved because of many reasons. Like if we are measuring anything, there is some error because of the system, because of environmental condition. So this error is denoted by delta. So error is very essential thing during the measurement. If error is more as compared to the measurement, then that measurement is not of any use. So the error is denoted by delta symbol, and it is defined as if we are measuring the volume, then its error in the volume, it is symbolized as delta of V. V is volume, where delta represent its error during its measurement. So simple way to look at the error, it is simply the difference between true value and approximate value. Like if we are measuring anything, then suppose its true value is x and approximate value is y, then difference of these two value, true value minus approximate value, it is called error. Although it is not very easy to calculate error in each measurement, but we can find the different type of reasons from where we can get that error. So here one example regarding the error. So statement of the example is, find the truncation error for x, capital X is equal to e raised to power small x if the first three terms in the expansion are retained. So this type of expansion like e raised to power x, sin x, cos x, tan x, this its expansion has infinite number of terms. So how many terms we want to consider depends upon the accuracy of the experiment. So we want to find true value minus approximate value, that is error. Its true value is 1 plus x square by 2 factorial up to so on up to infinite, while the approximate value, if we retain only 3 terms. So first term is 1, second is x, third term is x square by 2 factorial. So its approximation is if we keep only 3 terms. So the difference of these two comes under this error. So error is x cube by 3 factorial plus x 4 by 4 factorial plus x 5 by 5 factorial and up to so on. So if x is very small, then we can make this approximation, but if x is large, then the error is more because of the rest of the terms. So the conclusion is that if x is very less than 1, then we can approximate up to 3-4 terms. Otherwise we need to take at least 6-7 terms to reduce the error. So next are different type of error like absolute error, relative error and percentage error. So absolute error, it is the error in each measurement. Relative error is with respect to absolute error and mean error, while the percentage error is simply multiplication of relative error by 100. So next, like we define error, we can easily define absolute error. It is in each measurement. So it is the difference between true value and approximate value. True value is x and approximate value is x prime. So the difference of these two, it gives absolute error. So next is relative error. Relative error, it is defined as a ratio of absolute error to the true value. So absolute error is x minus x prime while the true value is x. Here one thing to be note that if we are making one measurement, then absolute error and error, they are same thing. But if we are making number of measurements, then absolute error is different for each measurement and relative error is calculated with respect to mean error of all the measurements. Next is numerical related to the absolute error. The difference between the measured value and true value is referred to as absolute error. So assume that the analysis of an iron ore by some method it gave 11.1% while its true value according to theory it was 12.1%. Then the absolute error is 11.1 minus 12.1%. So absolute error is minus 1%. While the relative error is the, here we can define more precisely percentage error. Percentage error is the ratio of absolute error to the true value into 100. So absolute error is minus 1, true value is 12.1 into 100. So this is percentage relative error. Next is relative accuracy. It is the percentage of the quotient of the observed result to the true value is called relative accuracy. So the true value is 12.1 and we observe 11.1 into 100. So it is 91.7%. Relative accuracy is 91.7%. So more close we are 12.1, so more accurate we are near the results. If this value, observed value is more as compared to the actual value, then we will get here 1 minus of that quantity. And percentage error we already defined, simply multiply 100 with relative error. So EP is equal to 100 into ER, where EP is percentage error, ER is relative error. So it is equal to 100 x minus x prime upon x, where x is true value and x prime is approximate value. So difference of these two give absolute error. Absolute error divided by true value, it gives relative error. So this expression is a relative error. If we multiply this expression by 100, then it gives percentage error. So next example, suppose 1.414 is used as an approximation to square root of root 2. Find the absolute, relative and percentage error. Square root of 2 is equal to 1.414 21356. We can take number of figures. So absolute error, it is the difference between true value and approximate value. True value is 1.414 21356 while the approximate value is 1.414. So absolute error here, it is equal to the difference of these two terms. So it is equal to 0.000 21356. This is absolute error in the measurement of square root of 2. Second thing is relative error. A relative error, it is defined as a ratio of absolute error to the true value. Absolute error we know already, it is 0.000021356 and true value is 1.414 So the ratio of these two will give us the relative error, and it is equal to 0.151 into 10 raised power minus 3. And third question is about the percentage error in the approximation of square root of 2. So percentage error is nothing but multiplication of relative error by 100. So ER into 100 give us percentage error. So while multiplying ER by 100, two zeros cancel. So EP is equal to minus 0.151 into 10 raised power minus 1. This is percentage error. Next numerical is if the true value of any physical quantity, it is 122 mm and expected value is 120 mm, then we need to find all type of error like absolute error, relative error and percentage error. So this is very simple numerical. One thing here to be note that the units are very essential while the measurement. So the units are same, so we don't need to take care much about the units. Absolute error, it is the difference between true value and expected value. True value is 122 and expected is 120. So the difference of these two is gives us absolute error. So absolute error is 2 mm, while the relative error, it is a ratio of absolute value to the expected value. So absolute value is 2, expected value is 120. So it gives 0.017. And percentage error, it is multiplication of relative error by 100. So relative error is 0.017 into 100, it gives 1.7%. So while solving any numerical related like this, so we need to take care about the what is the true value, what is expected value, and how can we calculate absolute error, relative error and percentage error. So we need to remember only these three formulas to calculate any type of error. These three are very important type of error. Next example is, given the expected voltage value across a resistor is 80 volt and its measurement is 79 volt, then we need to calculate the absolute error, the percentage of error, relative accuracy and percentage of accuracy. So these four things we need to calculate: absolute error, percentage error, relative accuracy and percentage of accuracy. So we know expected value is 80 volt while the measured value is 79 volt. So the absolute error, it is a difference between the expected value minus measured value. Expected value is 80 and measured value is 79. So the difference of these two, it gives us absolute error. So 80 minus 79, it is 1 volt. So it is equal to absolute error. Next is percentage error. Percentage error is defined as the ratio of absolute error to the true value multiplied by 100. Here the true value is equal to the expected value according to theory or any phenomena we need to consider here. So the difference of these two is 1 divided by 80 into 100 and it gives us percentage error is 1.25%. Third one is relative accuracy. It is 1 minus the a relative error, and it is equal to 0.9875, while the percentage accuracy, it is multiplication of 100 by relative accuracy. A relative accuracy is 0.9875 multiplied by 100, it gives us 98.75. So here there are four formulas: absolute error, percentage error we already defined, while the relative accuracy is nothing but 1 minus relative error, and percentage accuracy is simply multiply a relative accuracy by 100. So it gives us 98.75%. So next example is from the value in table 1.1. Here calculate the precision of 6th measurement. So 6th measurement is 100. So this is one experiment. We are making number of measurement on the value of xn. Here we are making 10 measurement on the same physical quantity, and the value we got from different measurement of the same physical quantity are given here in this table. So we need to calculate the precision in this measurement, in the 6th measurement. So here we take the concept from the random error. So these type of error, they are called random error because the same environment is there, same instrument is there, but they occur by chance. So these type of error, they are called random error. We need to measure the precision in the 6th measurement here in the 100, value of 100. For these type of numerical, first we need to consider the mean of these values, all these measurement. So the mean of the 10 measurement is equal to 100.5. So we can calculate easily. How? First sum up all these numbers of the measured value and divided by the number of terms. So number of terms are 10, number of measurements are 10. So the value is 100.5. This is average value. So if we want to calculate the precision, we simply need to take 1 minus the 6th value minus the average value upon average value. It means this is true value. So 1 minus relative error, it is called precision. So 1 minus 100 minus 100.5, it is mean value, divided by 100.5, it is equal to 0.995. This is the precision in the 6th measurement. So precision means how accurate we are in the measuring of this physical quantity at the 6th time here. More close this quantity to the actual value, more precise we are in the measurement. Next error is limiting error. So one numerical related to this, given for a certain measurement, a limiting error for the voltmeter at 70 volt is 2.143% and the limiting error for the ammeter at 80 milliampere is 2.813. We need to determine the limiting error of the power. We know power is equal to VI, where voltage is 70 volt and current is 80 milliampere. So the error is simply sum of these two errors. So error in voltmeter is 2.143 and the limiting error in the ammeter is 2.813. So the total error in the power, it is simply sum of these two errors. So the sum of these two error gives us 4.956%. Next numerical is relative error. So what is the relative error in the approximation of x is equal to 2.0 to x is equal to 1.98? A relative error is equal to, this is simply the simplification of the earlier formula, x upon x minus 1 is equal to 2 upon 9.18 minus 1. So, it is equal to 0. Up to how many decimal we want, we can write this answer according to the requirement. So, next numerical, a analog voltmeter is used to measure voltage of 50 volt across a resistor. The reading value is 49 volt. Find the absolute error, a relative error, accuracy and percentage accuracy. This is very simple numerical. So, error is simply the difference between true value and approximate value. So, the true value is 50 and the approximate value is 49. So, difference is 1 volt. A relative error, it is a simply ratio of 1 divided by 50 into 100 and it is equal to 2. Next is accuracy, it is simply 1 minus a relative error. So, a relative error is 1 by 50, so it is equal to 0.98, and the percentage accuracy is simply the multiplication of this term by 100, so it is equal to 98%. Next numerical is like previous numerical, where we calculate the precision in any measurement. It is exactly same. So, an experiment conduct to measure 10 values of the voltage and the result is shown in table below. Calculate the accuracy of fourth experiment. So, these are number of experiment, 10 experiment we did. These are the values which we get from each measurement. So, we want to calculate the precision in this measurement. I already told you that if we want to calculate the precision in any measurement, we first need to calculate the average value. So, average of all these values is equal to 101.1. So, this is average value. So, the precision is 1 minus a relative error. So, relative error is 1 minus 97 is its value minus this is actual value 101.1 divided by 101.1. So, its precision is 96% approximately. Next numerical is a class 1 voltmeter with range 100, 250 and 1000 volt is used to measure the voltage source with 90. Calculate the range of voltage and its relative error. So, we need to calculate if we are using 100 range volt, 250 range volt and 1000 volt range, then what is the error in the measuring of the voltage with the source of 90 volt. So, error is equal to, for the 100 voltmeter, it is equal to 1 upon 100 into 100 is equal to plus minus 1. So, after minus 100 volt is the central value. If we take plus 1, so it is equal to 101, and if we take minus 1, then it is equal to 99 volt. So, 100 volt plus minus 1 volt, it goes from 99 to 101. So, the error in the measurement is very small here, and percentage error is simply the relative error into 100. So, this is the difference, means this is absolute error divided by true value into 100. So, it is equal to 1.11. This is percentage error in the measurement. So, this is for 100 voltmeter. But if we are using 250 volt voltmeter, then the precision and error, they are different. So, for the 250 voltmeter, we can easily get 1 upon 100 into 250. So, it is equal to 2.5 volt. So 250 is central value plus minus 2.5, it is equal to 247.5 up to 252.5. So this is a range we can get the value. Next is percentage error in this measurement. So percentage error is equal to absolute error divided by true value into 100. So the relative error is 2.5 divided by 90 into 100, it is equal to 2.77%. So more range voltmeter we are using, more error we are getting for the measurement. For the 1000 voltmeter we are getting error to be plus minus 10. So it range from 990 to 1010. So percentage error is nothing but absolute error divided by true value into 100, it is equal to 11.11%. So more range voltmeter we are using, more error we are getting in each measurement. Next numerical is the accuracy of 5 digital voltmeter are checked by using each one of them to measure a standard 1 volt from a calibration instrument. The voltmeter readings are as follows: 1.001 volt, second voltmeter, these are the readings the 5 voltmeter are giving. So we need to calculate the average measured voltage and average deviation. So here we need to also calculate the average deviation. So first we calculate the average measured voltage. It is nothing but the sum of all these terms divided by the number of measurement. So here we are taking 5 measurement, V1, V2, V3, V4 and V5. So the total value is, after the sum of all these terms divided by 5, it is equal to 1 volt. So deviation of each measurement from the central value, it is equal to 1.001 minus 1. So we can calculate the deviation for each term like we calculate for V3. So V3 is 0.999, so deviation in that reading is equal to 0.999 minus 1 is equal to minus 0.001. So total deviation, total average deviation, it is simply the average of these deviations divided by the number of measurement. Here the number of measurement are 5. So here one thing to be note here, that this is the absolute value. So absolute value for the first reading is 0.001, for the second is 0.002, third one is, after neglecting this minus sign, it is also equal to 0.001 because we are taking absolute value, and fourth is 0.002 and fifth one is 0. So the average deviation is equal to 0.0012 volt. Next numerical, a project budget surplus of 17 billion turns out to be 20 billion at the end of fiscal year. So we need to calculate the absolute error and relative error. So project was of 17 billion, but the total sum of expenditure is 25 billion at the end of fiscal year. So the absolute error, it is a difference between measured value and true value. So 25 minus 17, it is 8 billion, and relative error is the ratio of absolute to the true value. Absolute is 8 and true value is 17. So the ratio of these two, it is 47.1%. So the relative error is more. Here we can easily see it is 47.1. So the difference of these two value gives us the absolute error, and the ratio of absolute error to the true value, it gives us a relative error. So the next numerical is uncertainty in the measurement. Suppose we are making any measurement of a ruler with 1 mm smallest division. So the